Alright, hell yeah. So the objective of this video is to go over fundamentals of trigonometry, sines, cosines, tangent, cotangent, secant, cosecant, and fill in these triangles. Two objectives. One, advanced objective, is to look at these and identify what's going on here, and identify that each of these has kind of two different scenarios that play out. And so one of the simplest fundamentals that you can take from this video is, I think everyone knows Pythagorean's theorem. This side squared plus this side squared is equal to the hypotenuse squared. So for this video, it's important that we already take the square root of both sides, leaving c is the square root of a squared plus b squared. So this should be a visual representation of this equation. But this solved for the hypotenuse. So the other fundamental is to know how to solve for one of the sides and to look at this form. How I memorize it is I have the bigger number, the hypotenuse, subtracted by the side to get the length of the side. Still think of these as lengths. Hypotenuse is always going to be the larger of the values over a and b. And so you're going to take the hypotenuse squared minus a side squared, square root that. That's going to give you the other side. If I want to find this side, hypotenuse squared minus this side squared all over the square root. So hell yeah. Okay. And alright, booyah. And might as well try to dive into the harder part, and then we can go through kind of the easier part. I think that's a pretty good way to do it. And so what do we have here? We said this is going to be the hypotenuse. So cool, we're going to put that number 1 as the hypotenuse. Because the hypotenuse is the only, a triangle, a right triangle has one hypotenuse and two sides. So in both scenarios, this 1 has to be part of the hypotenuse, but this can be a side minus a side. Remember that? And so this value of x can either be here or there, and so you know what I mean? Well, if this is 1, this is your triangle, and we're going to reference this in this video. But this is the simplest way to represent a right triangle, where your hypotenuse is 1, and your sides are sine theta and then cosine theta. Sine is always across from the angle. I put a sun shining rays and think sun is shining on the sine, and hell yeah. Okay, so from that perspective, that's going to be the simplest, because if this is 1, this is sine theta, x has to be cosine theta. Cool. And even in this one, I didn't write in that this is sine theta, this is cosine theta, x right here is cosine theta, and then x right here is sine theta. And then so let's put the value of x into this equation. So we're going to have 1 minus cosine squared theta. And then what would this be? We just said the hypotenuse squared minus the other side squared is equal to the other side. So hypotenuse squared minus this value of x squared, take the square root of it, is equal to the other side. Hell yeah. Okay, so here it's a little bit trickier, because we have 1 plus x squared. And so if we come here, we have this scenario going on, where if you have a plus here, we must be adding the sides. So a squared plus b squared. So this means that 1 is associated with one of the sides, and then x is associated with the other side. If this is 1, we have to come back to our triangle, our basic triangle, and to get a 1 right here, we need to divide this triangle by cosine. We need to divide all 3 of these by cosine. So cosine over cosine is 1, sine over cosine is tangent, and that's going to be my value of x. And then 1 over cosine theta is the hypotenuse. How did I know this was x? Well, I looked at this. This is a side plus a side. So I chose one of the sides to be 1, the other side's x. And that's why we have 2 different ways to represent this, because I could represent this 1 as this side. And then this is going to be the x. But let's finish off with this one. And so this is going to be a side squared plus a side squared equals the hypotenuse. And so we're going to have 1 plus tangent squared theta. Square root of that is equal to 1 over cosine, which is secant theta. Cool. If we do it the other way, we put the 1 here. How do we get this to be 1 from our simple triangle? Well, I'm going to divide sine theta by sine theta. And if I do that, I have to divide everything by sine theta. So the hypotenuse gets divided. That's going to be cosecant theta. And then this is going to be cosine divided by sine, which is cotangent. Sine over cosine is tangent. Cosine over sine is the inverse of that. That's cotangent. So that should be easy to see. And then we have, and this is my value of x. If I'm choosing, if this is a side plus a side, I chose this as my side. This value of x has to be this other side. And so, hell yeah. And so we're going to have 1 squared plus cotangent theta squared is equal to, or the square root that is equal to cosecant. So that's what we have here. Okay, the last scenario, probably the trickiest. X is in the spot of the hypotenuse. You know what I mean? And we only have one place that we can put that value of x. But this is subtract one of the other sides. We can either put that side here or here. So again, to get this value of 1, we got to divide by sine. So this is sine theta divided by sine theta is 1. This is cosine theta divided by sine theta is cotangent theta. And this is 1 divided by sine theta. And that's what I'm representing as x. Hell yeah. And this is going to be the hypotenuse minus one of the sides. This side gives me the other side. So the answer should be cotangent theta. And let's plug it in. 1 divided by sine theta is cosecant theta. So we're going to have cosecant theta squared minus 1 squared is square root. That is equal to cotangent squared. The only thing that I don't have is a square root on all these 1s. You can put that in if it's your first rodeo. Hell yeah. On this triangle, it's not going to have a square root because we haven't done the Pythagorean theorem yet. You know, we haven't taken this squared plus this squared is equal to that. You know what I mean? And in this case, we're trying to find, because of this minus sign, we're trying to find the length of one of the sides. We have the hypotenuse minus this side. We're trying to find the length of this side. And so, hell yeah. And that's what we have right here. So, again, cosecant theta squared minus 1 squared, square root that, is equal to cotangent. And we're just jumping ahead. We're doing the Pythagorean theorem. Even though if you had, like, hey, if I wanted to find this side squared, I'd be like, well, let's set it up like this. A squared plus b squared is equal to c squared. But I'm really interested in this. So let's get the b to the other side. Hell yeah. And now I can take the square root. But that's what we're trying to do all in one step, just so we can recognize these patterns in other problems. And I think that's a really good thing to do. Okay, last one. Hypotenuse is x. The other side right here is going to be 1. This was cosine theta. To get this as 1, I got to divide the entire triangle by cosine theta. And so this 1 upstairs is going to, 1 in the hypotenuse is going to divide by cosine theta. That's going to equal secant theta. And then this sine theta divided by cosine theta is tangent theta. What are they after? They're taking the hypotenuse minus this side. They're trying to find this side. So that's going to equal tangent theta. And then let's throw in this value of x. So we're going to have secant theta squared minus 1 squared, square root that is tangent theta. Hell yeah. So you know what? I think that's going to be a video. And then for a simpler video, we're just going to fill in these. But you know what I mean? That's kind of an advanced in-your-face, and that's 10 minutes. So that's pretty good kind of going over that. So part 2 is just going to be filling in these triangles. We're going to do the same thing, but it's just kind of going to be a little bit simpler. And you know what? We got 20 minutes. Let's just do it. So we have, or do I want to do this in 2 parts? I think I do. Let's do it in 2 parts. Hell yeah.